Okay, we're going to look at critical angle now. So the critical angle is the angle above which total internal reflection will happen. So if we imagine a situation where we've got an interface here between two media, and this medium, n we'll say is large, so let's say it's n is equal to 2. And this medium up here, so this is like air or something, so that might have n equals 1. So as long as the refractive index is higher down here than it is up here, and your ray of light is leaving in this direction, eventually you'll hit an angle of incidence here. And my angle of incidence, we'd have to remember that the angle of incidence here is with respect to the normal. Eventually we'll hit an angle of incidence here which is equal to c. And c will be the critical angle. And when you have this scenario, the angle of incidence here, the ray of light will hit the interface in such a way that the ray will be refracted 90 degrees. And so you'll get the ray of light running along the interface here between the two media. So this is the critical angle, and if you increase the angle of incidence here greater than c, you'll get total internal reflection. Your ray of light will come back into the n equals 2 material again. So what we're going to look at is the typical type of mathematical question that comes up for this, and I'm going to use diamond as an example. So when we look at diamond, we'd see that the refractive index of diamond is 2.4, and remember there's no units on refractive index because it's just a ratio. So refractive index of diamond is 2.4, and the question would be, well, what's the critical angle? So we want to know what c equals question mark. What is c? So we will start with the formula. N is equal to 1 over sine c, like that. And c is what we're looking for, remember? So we'll plug in values now, and the only value we need is 2.4. is equal to 1 over sine c. Now we have to rearrange this. We have to rearrange this formula a little bit. So in order to do that, we would have to try and get rid of this fraction. We would want to multiply across the whole thing by sine c. So if we multiply this side by sine c and that side by sine c, well then the sine c's will kind of cancel off on this side, and you'll end up with 2.4 times sine c is equal to, and here our sine c's will cancel, I just end up with 1 on this side. Now I want sine c on its own here, so I'd have to divide across by 2.4. So I get sine c is equal to 1 over 2.4, like that. If I divide this side by 2.4 to get rid of the 2.4, because it's multiplied by the sine c, well then I have to divide this side by 2.4 as well. So now I have sine c is equal to 1 over 2.4. So let's see what 1 over 2.4 is. 1 divided by 2.4. And I get a value of 0.4167. So sine c is equal to 0.4167, like that. And I just want c. So in order to get rid of this, now this is something that students find a little bit tricky at times. In order to get rid of this sine, the sine is operating on the c, if you want to think of it that way. Sine function operating on c as the argument. So I want to get rid of the sine. So I would need an inverse function to get rid of that. So I would want the sine inverse of sine c. That makes sense. So sine inverse of sine c. And this sine inverse will get rid of that sine. They're like they're the reciprocal of each other. But because I've done sine inverse on this side, I would need to also do it on this side. So sine inverse of 0.4167. Right? So what I end up with then in the end is that the sine inverse of the sine of something is just the argument on its own. So I'll end up with c here. If you want to think of it this way, it's not really a very correct way of thinking of it. It's like these cancel, but it's not a good way to think of it. But that is it'll get you away if that's what you need for this physics part. It's not good maths. And so in order to answer this now I've got my angle back, I want the sine inverse of this. So because I've already got the answer up on the screen, I can do sine inverse. And to get sine inverse, I need to hit, on this calculator, shift and sine, and that will bring up sine inverse. And because I had the answer up a second ago, I can hit answer, and then I can close the bracket and hit equals. And what I get as an answer for that is 24.62 degrees. 24.62 degrees. And this is the critical angle for diamond. And we need to make sure we keep degrees on here because it's an angle is what we're looking for.